Rational expressions. Finding the least common denominator. Finding the least common denominator. Step 1. Factor all the denominators. Step 2. Circle the greatest occurrence of each type of factor in the factorizations. Step 3. Multiply the circled factors. For our first example, find the LCD. We have 3 fractions and we'll break each one down. So for our denominators we have 2x squared, and 2 is already prime, and we'll just break down the variables. X times x. Next we have 6xy. We'll break the 6 down. 6 is 2 times 3, and we have x and y. And then we have 18y squared. And you can do 18 on the side. Let's see, 18 is 9 times 2. And 9 is some 3's. So we have a 2 and 2 3's. And we'll break down the y's. Now we have everything factored. We're going to take our factors from the one where it occurs the most times. I have to represent every kind of thing. So for my 2's, it occurs once, once, and once. So it's the same in all, so it doesn't matter. Take it from either one. Right? For the 3's, the first one has none, 1, and the last one has 2. So the 3's will come from there. The variables work exactly the same way. So I have 2 x's, 1, and none. So I'm going to need 2 x's. For the y's, I have none, 1, and 2. So it will come from the last one. So for our LCD, we have a 2, we have 2 3's, we have 2 x's, which is x squared, and 2 y's, which is y squared. 9 times 2, 18, x squared, y squared. Let's look at another example. So we're going to find the LCD, and we will just break each denominator down. So our first one is 4m n to the 4th, and 4 is 2 times 2. We have an m, and we're going to have 4 n's. Next we have 14 m squared n cubed. 14 is 2 times 7, and m squared is 2m's. N cubed is 3n's. And 35, how about 5 times 7? So let's write it first. 35 mn, and then we'll break it down. So 5 times 7, and an m and an n. Now we're ready to pick our common denominator. So we're going to take each type of factor we have. So we're going to need 2's, 5's, 7's, m's, and n's. And we'll take it where we have the greatest occurrence. So the 2's are going to come from the first one. For the 5 will come from the last one. And the 7's. The 7 occurs once in each of those. So it's in any one, it's only one time. So we need 1 7. For our variables, for the m's, we have 1. In the second one, we have 2, and we have 1. So the greatest occurrence is 2. So that'll be an m squared. And for the n's, we have 4 n's in the first one, 3, and 1. So the greatest occurrence is 4. And then we'll just multiply our numbers back together. So 35 times 4, 140 m squared n to the 4th for our LCD. Now we're ready to find the common denominator for some denominators that are not just monomials. These are already in factored form except for the numbers. So let's write them down. So we have a 5 and an m plus 2, and another m plus 2. That's one denominator. 15, we will have 3 times 5, and we have an m plus 2 and an m minus 1. So all of these are different types of factors. M plus 2 is different from m minus 1. And so we will pick out our LCD. You take it from the one where you have the greatest occurrence. So first we'll do our numbers. For the 3, it only occurs in one of them and once, so we will need a 3. The 5 is in each one, but in one it only occurs one time. So we will need a 5. And then the m plus 2's. The first one has 2 copies of m plus 2's. The second one has only 1. So the m plus 2 occurs twice in the first one. So we will need the greatest occurrence. And we have one other type of factor, the m minus 1. So we will also need it. And to multiply out, we will only multiply our constants. So 3 times 5, 15. We will leave the rest in factored form. So 2 copies of m plus 2 and an m minus 1. That is our LCD. For our next example, we will first need to factor each denominator. And so for the first one, this is a difference of squares. So we have an x plus 2 and an x minus 2. For the second one, we have a trinomial, 2 sets of parentheses. Can do our signs, different signs. Split the x's, and we're going to use a 2 and 1. You want to get a minus x in the middle, so we're going to need the 2 to go with the minus. And you can check minus 2x plus 1 gives a minus x. All right, so for our LCD, we have x plus 2 and x minus 2 in one fraction. In the other one, we have an x plus 1 and an x minus 2. So listing our factors. And then our LCD, we will take each type of factor from the one where it occurs the most times. So first of all, for our x plus 2, it's only occurring in the first one, and it occurs one time. So we will need an x plus 2. X minus 2 occurs in each one, but in any one fraction it only occurs once. So we will need an x minus 2. And also the x plus 1, and it only occurs once in this one and none in the other. So you take it from the one with the most. And this will be our least common denominator. We're not going to multiply these out. We will just put on the missing pieces as they are. So this is our LCD. For our last example, we have denominators that are called opposites. You can actually get one from the other by just factoring out a negative 1. The only difference is they have opposite signs. So if we do factor out from the second one a negative 1, that would leave a negative 3 plus x, and then they match the x and the minus 3. So for our LCD, for this case, you can actually use x minus 3 or 3 minus x. It doesn't matter, and you do not need both. You just need one of them.